Okay, Algebra 2 folks, this is just going to be a little video here to get you back in the swing of things with factoring. We're going to look at several different ways that we can factor in different situations that come up, all of which can be very important for you, not only in this chapter, but moving forward in the second half of Algebra 2 and pre-calc if you decide to go that way. So we're going to start basic stuff here when we have an expression that simply has nothing more than the greatest common factor. Now, when we deal with this idea of greatest common factor, we have to look at both numbers and at variables. So if you're taking notes on this, you want to make sure you're looking at both numbers and variables. And exponents are going to be the key with our variables. So we'll write that down too. And then numbers just deals with factors of each. So in looking at this expression, we have 8x cubed minus 6x squared. Pretty basic. As you go forward with this, we're looking for things they have in common. It's like reducing a fraction almost. So what you kind of ask yourself, what's the biggest number I can take out of both 8 and 6? We're talking, when I say take out, we're not talking subtraction, we're talking division. So as I look at this 8 and 6, well, the only number that they have that is a factor of both of them is 2. So as I take this out, if I kind of write this off over to the side here, if I write my GCF as my greatest common factor, 2 is going to be the number portion because 8 and 6, they share a 2. If you were reducing the fraction 8 over 6, you would divide both of them by 2. So that's a way of thinking that to figure out what number comes out. Now, as far as the variable goes, I think it's needless to say that they both have to have the same variable because obviously you can't take an x out of y. But in this case, we want to make sure the variables are the same. Now, it's an all or nothing type deal here. If only one of them has a variable, then I can't take it out, so there's nothing in common. Everything in the expression has to have the same variable or the same numerical factor in order to factor out that number. Okay? I think factoring is dividing out, essentially, is what we're doing. So the easy part to look at with exponents, or with variables, again, we said over here, exponents are key. So when we look at this particular example, I see x cubed and x squared. Now you can't take out more than you have. So in this example, 2 is smaller than 3, so the most I can take out is an x squared. If there was just a single x there, I wouldn't be able to take that out anymore either. So that's my greatest common factor when we do this. So when we write this in factored form, okay, we start by writing out what is my greatest common factor. We found that to be 2x squared. Now, that's divided out. So we're basically doing the opposite of the distributive property. Distributive property, I take this and multiply it in here. But in this case, we're actually taking it out of both terms. So we're just dividing out. So if I have 8 divided by 2, I get a 4 out. Okay, so that's that kind of first term. And then with exponents, all we do is subtract. Well, I had x cubed. I took out x squared. That leaves me with just x, because 3 minus 2 gives you 1. Okay, now in the next term, we're done with that first one. Negative 6 divided by positive 2 is a negative 3. And then I had x squared. I took x squared out, so I have no x's left. So there's no x here. So I finished. I've completely taken everything out. So when we look at factored form, this is the complete factored form of this expression. Okay, so this goes to this. All again, just divided out a greatest common factor. All right, that's factoring just a simple expression that has something in common. As we move forward, we're going to look at other times we don't have this, specifically trinomials. Okay, the next kind of couple slides here are going to be focused on trinomials. Now, this says method number 1. I'm going to show you 2 methods. If you know a different way to factor that gets you the results you need, great. To me, the method I'm going to show you right now is the most efficient. It's the most organized as we go through. So it's up to you how you feel you want to factor things. So we're going to start out here. First, number 1, you need to make sure your leading coefficient is positive. So a real important thing, your leading coefficient must be positive. If it's not, you have to factor out a negative 1 first and then go from there. Factor the leftovers. So leading coefficient must be positive. Okay? You have to be in standard form. And we learned that on Friday was that ax squared plus bx plus c, and we have that there. And then from there we can go through and do our little method. Okay, so bear with me here. You might want to jot a couple notes down as we go on what I'm doing so you understand why I did what I did. So first things first, I call this the box method because you've kind of seen this before when you multiplied stuff out, but I like this. It looks like a Punnett square, and you guys have seen those before. So first we're going to make a little box here. So I come out, I make a 2 by 2 box. In fact, you're going to try no, I'm going to do 2 by 2s. First things first, take your first term, it goes in the first box. So 6x squared goes to 6x squared. Okay? Then you take your last term, throw it in the box. Now, the nice thing about this method is that there is no reason to put signs in the box. You don't have to worry about positives and negatives. We can do that at the very end. So this part, just put stuff in as we go. Now, to fill in these last two squares here is where we have to kind of do a little kind of tweaking of what we have. And so to get that, we're going to first multiply 6x squared and 8 together, and we're going to get 48x squared. Again, I'm ignoring signs. I'm going to do that in the end. Those are going to tell us some different information, but we'll start with doing this. So to get these last two spots, what I'm looking for, okay, are factors of 48. So numbers that can multiply together to get 48. Factors of 48 x squared. That, and then the next word is based on your constant, and we're going to talk about that subtract, okay, because, and I'll put in parentheses, your constant is negative. It would be addition if your constant was positive. Okay, that's going to be a little close here, so I'm going to write this down here. It's negative. Okay. That subtract to get negative 13. Okay, so that's what we're looking for, your factors of 48. So I'm going to write 48 over here, and we're just going to start listing our factors of 48. Now, hopefully at some point you can know your factors well enough, your multiplication facts, so you can just know these off the top of your head. But I'm going to list them. So 1 and 48, first of all. Okay. 2 and 24. You get 3 and 16. 4 and 24. I'm sorry, 4 and 12, not 24. 4 and 12. And then 6 and 8. So those are your factors of 48. Now, they need to have a difference of negative 13. Well, 1 and 48, not even close. 2 and 24, not even close. All right. 3 and 16 have a difference of 13. Now, I want a negative 13, and we'll get to that point in a second, but 3 and 6 are going to give me what I want. All right. So I'm going to go in there and write those in the box. Now, not just 3 and 6, I have to account for the x as well. So it's 3x. And 16x. I think I said 6. Sorry, I meant 16. All right. So I filled in my Punnett square now, or my factor boxes here. And then to get what we have out, we're going to go back to what we just talked about in the previous little slide about dealing with greatest common factors. So I'm looking at rows and columns. You kind of think of that rows and columns. We've made a little matrix almost here. We're just going to factor rows and columns and figure out what they have in common. So let's look at 6 and 16. Well, they share a 2, and they both have x's. Now we have x squared and x to the first power, so the most I can take out of there is x to the first power. Coming down to 3 and 8. Well, 3 and 8, the only thing they share is a 1. They both do not have an x, so I can't bring it out. So that's all I can do is a 1. Go to the columns and do the same thing. It doesn't matter if you write it on top or bottom. It doesn't make a lick of difference there. So let's look at 6 and 3. Well, 6 and 3, they share 3. That's the greatest common factor. They both have an x, but this is x to the first power, so that's the smallest I can take, so it's just x. 16x and 8, no, they share 2, they share 4, but the greatest common factor is 8. And we always want the greatest common factor. Okay? Now, here's a spot you can check to make sure you took out the greatest common factor. Right? You can multiply your spots together. So if I multiply 2x and 3x, I should get 6x squared. I do. That's what I want. If I multiply 1 and 8 together, I get 8. That's what I want. So that's a check here for you. If you don't get those first and last products, you did something wrong. Go back and make sure you took out the greatest common factor that you could. Okay. So I have my two factors here. And I'm just going to put them in the box. And again, we haven't assigned any positives or negatives yet. We'll do that right here. Okay? And that goes, we're going to talk about some different products here to help us determine what goes where. So I'm going to look at my inside product first, like 1 and 3x. That gives me 3x. And then I'm going to look at my outside product, 2x and 8. That's 16. Okay? I have to determine what's going to go where. I need a negative 13. So I have to think, what do I have to do with 3 and 16 to get negative 13? Well, if I do 3 plus 16, that gives me 19. That doesn't work. If I do 16 minus 3, that gives me 13, but I need a negative 13. So what I need to do is have a positive 3 and a negative 16 will give me a negative 13. So when I assign those, the positive 3 came from this product here, so I put a positive here. The negative came from the outside product, so that goes on the outside multiplier. So what we've done is factored this completely. I use called the box method. I don't know, there's probably a technical term for it, but I like the box method. We've determined that we have nothing in common here. We've multiplied our first and last to get us a common factor here. We filled the box in using factors of that number, and then we took out the greatest common factor of your rows and columns, and then we assigned the correct positives and negatives to things. So this is your final answer in factored form. If you look, 2x and 1 share nothing other than 1. That's what we want. 3x and 8 share nothing other than 1. That's what we want. You know you've kind of reached your goals when you got to that point. Okay. Well, let's continue on here. I'm actually going to skip the other methods because I think presenting you just one is going to be good enough. We can talk at a different point if we want to. All right. So we're going to take these last couple slides. We're going to look at two special types of polynomials. One is called a perfect square trinomial. One is called the difference of two squares. And we'll get to that one next. But let's start with perfect square trinomial. Okay. A couple different things happen here. First and foremost, there's a positive leading coefficient. So 4 is positive. That's good. Right. The first and last terms are perfect squares. Now, 4 is a perfect square because if you take the square root, it comes out to a whole number. 9 is a perfect square because if you take the square root of that, it comes out to a whole number. So that's what we're looking for. And it says twice the product of the roots results in the linear middle term. Linear is the middle term. So what they're saying, if I have a perfect square, say a squared, and I end with a perfect square, b squared. If I take the square root of both of those, okay, the square root of a squared is a, that's the root. The square root of b squared is b. Okay? If I take those square roots, and it says twice the product, so plus 2 times their roots, which would be ab. This is, by definition, what perfect square trinomials look like. Okay? So I want to, if I can show you that this works first, because if I look at 4x squared, well, 4x squared, the square root of 4x squared is 2x. And we can even break it down to this. 2x times 2x. 9 is a perfect square. It's positive 9. That's 3 and 3. Well, what they're saying is that when you factor this, or to tell it is a perfect square, if I do twice the product, so 2 times, the product would be 2x times 3. Those are my roots. Well, 2x times 3, that's 6x, and 2 times 6x is 12x. There's 12x right there. That's my middle term. So that shows me that I have a perfect square trinomial here. Now, when they factor it, there's a pattern that factors in. This factors into something real easy here. Well, you take your two roots. Remember, roots are, we took the square roots, a and b. Throw them in a set of parentheses. Now, it's a perfect square trinomial, so we're going to square it. And then all we do is take the middle sign and throw it in between. All right? If you had a subtraction in the middle, it would be the same idea. You'd have a and b, because those are the square roots of a squared and b squared. Now I would just put a minus sign in the middle. Again, this guy makes minus. So if we take our attention back to this idea, I had this with some numbers here. I look at what I have. I showed you already that if I do 2 times their product, I get my middle term. That's good. I want that. I can factor this very easily into one of these two forms. So all I do is take one term from here, one term from here. You get 2x and 3, square it, and then just take the sign in the middle, so plus. Now, if you wonder why it works that way, I know some of you are just dying to know why it works, not just be shown the answer. If I go through and factor this like I did before, I'll do that really quickly. We'll make the box. Put my first term here, 4x squared. Last term down here, 9. I multiply these together, I get 36x squared. So I need factors of 36 that add to 12. Well, that's 6x and 6x. If I factor my rows and columns, 4 and 6 share a 2, and they also share an x. 6x and 9 just share a 3. If I look, I'm doing the same thing here. 4x squared and 6x share a 2. 6x and 9 share a 3. So that's the same idea. If I put them in parentheses here, 2x cubed and 3, 2x and 3, and I need a sum of 12. Well, inside product is 6x, so is the outside product. So the only way to get my answer is plus and plus. So I'm just doing the method I just showed you. And if I look, I'm multiplying 2x plus 3 by itself. By definition, that means you are squaring it. So we have a shortcut way that we can use it, but this is where it comes from. I factored it normally. You get the same product, and your result here is going to be what you're looking for, is the squared. Now, as we go through and do some more work with quadratics, it's going to be imperative that you realize that if these are the same, you need to write them as squared. Because when we move forward with solving these, it's going to make life infinitely simpler for us. There's perfect square trinomials. Lastly, difference of squares. Okay. Difference of squares have two terms. Okay. Both are perfect squares, so term 1 would be a squared, let's call it that. The second one would be b squared. Okay. And there's subtraction, so a minus in between. So as you look here, it looks kind of like this last one over here, but I don't have a linear term. Okay, so I'll kind of add a 4 to here. There's no linear term. There's no middle term. So that would actually end up being 0. And as I go through and do this, it behaves, it's kind of a combination of my trinomial method and my perfect square trinomials. And it still has a pattern. If I do this the long way out here, as we did before, I'll get you a concrete example here in a second. Let's say I have 4x squared minus 25. Okay. Well, if I look, I have two terms. That's great. Check 1. Number 2, both are perfect squares. 4 is, x squared is, and so is 25. Awesome. Do I have subtraction? Yep. And there is no linear term. So as I go through and look at this, I can factor it the same way that I did before. I can throw 4x squared here and throw 25 down here. Okay. Well, if I multiply these together, I get 100x squared. And as I look, as I did before, going way back here, I need factors of my product that have a difference of my middle term. Well, the problem here is I have no middle term, so it's 0. So I'm looking for factors of 10, or 100, excuse me, that have a difference of 0. That's going to be 10x and 10x. Okay. And if I can go through the same process as I did before, rows and columns. So 4x squared and 10x, they have a common factor of 2 and an x. 10x and 25 have a common product of 5. Okay. Columns now, I'm doing the same thing, just like a perfect square trinomial. So 2x and 5. So my parentheses will once again be looking exactly the same as I start. So I factored it out. Now, here's the difference between perfect square trinomials and difference of squares. If I do my products, my inside product is 10x, and my outside product is 10x. Okay? We did this over here. We look back. Same with here. Here was a 6x, and it was a 6x as well. The difference is I need to have a difference of 0. So how do I get 10x and 10x to give me a result of 0? I make one positive and one negative. It doesn't make a lick of difference which one it is. So one of these has to be plus, and one of these has to be minus. Now, you're going to look at this and say, hey, it's the same thing. Why don't I just write squared? But it's not the same thing. This is where your mistake is going to be made. Here I have a plus, here I have a minus. That is definitely not the same thing. Okay? So what we've done is taken this and broken it down into its factors again. So this becomes 2x and 2x. This is 5 and 5. And so I've taken both sets of factors and thrown them in parentheses and just made 1 plus and 1 minus. So real quick, another example, if I had 16x squared minus 81, let's say. Okay. So 16 is a perfect square. That is 4x and 4x. 81 is a perfect square. That's 9 and 9. So when I do this, I know that works out. What do I have? I have two terms, the difference, and they're both perfect squares. So I just write two sets of parentheses, throw my factors in them, 4x and 9, 4x and 9, and then just make 1 plus and 1 minus, and you're all set. Okay. So that's your crash course. I don't think there's more here. That's your crash course in factoring. Make sure you take good notes and then stop it, go back, watch it again. It's going to be imperative that you guys know how to do this really well moving forward here in Chapter 4, and then again in Chapter 5 as well. So get the notes down, watch it a couple times, and make sure you're understanding what's going on. Get in before or after school to make sure you're getting some help as well so we can be as successful as possible. So that's it. Have a great weekend. Hope you enjoy yourself, and we will see you on Monday.